put together a slide set to summarize the recent changes to S2020, and are glad that you could join us today. As you know, standards is a ongoing evolutionary process, and every 5 years the association is required to upgrade or to review and change, if necessary, standards. And that was done in 2014, and the changes are listed on the ESG Association website, so you can go there to see them as well. We are going to present today an interpretation of those changes and help share with you the intent of the changes. We do have concerns about some of them, and we disagree with some of them as well. However, in the spirit of constructive suggestions for continuous improvement, we will offer our recommendations for those areas that are in question. And you'll see in a moment here a slide coming up with the rules of engagement. I'm waiting for your screen to show that. It's taking a while to get there.
It's up on my screen, Ted.
Oh, is it? Okay, good.
Yeah.
So what I wanted to point out is that right now everyone's line is muted. So if you but on the other hand, we would like to encourage you to ask questions, and you can do it one of two ways. You can raise your hand through the webinar dialog box and let me know that you would like to say something, and I'll unmute your line. The other possibility is to send a text message, perhaps through the question. Let's use just the question box. You can send your questions that way, and we'll respond to them as we go through. We are recording this session, and it will be available on our website next week. So with that, I'm going to move on to the next slide. We have a few brief introductory remarks, and then we'll get into the strengths of S2020 as well as the changes, and then again the recommendations we have, as I said, that we're offering in the spirit of constructive improvements for the future. Before we get into that, I just wanted to let you know that we have once a year we have a workshop here at my office in New England, and we'd love to have you join us. The only thing you might want to consider is that we're right now in the snow belt, and this is literally what we are looking at. In the last, actually, in a 3-week period, we received or dumped on with 8 feet of snow, and you can see this is part of my house, and the snow is up to the roof, as well as over the roof of the shed in the back. Now, in July, when we have the workshop, there's a little different view, and might be a little more appealing. Anyway, hope you can join us, and also enjoy some good weather in July. Now, there are a few terms that we'll use today, and I'm not going to dwell on these. I'm going to just step through them briefly so that you can think about them a little bit. Most of them should be very familiar to you. This third one, perhaps not. Terry Welcher and I, when we were at AT&T, developed a benchmarking process that we used for AT&T because of the huge nature of the company. And since then, we've refined it, and we'll refer to it in this slide set. And again, a few more terms that I expect you're familiar with. In terms of Class 0, that definition has been clarified a great deal by the association. In this presentation, if we say Class 0, what we're saying is that it's a device that fails for either HBM or CDM below 250 volts. And then there are categories defined by the association. 0B is less than 250. 0A is less than 125. And we recommend a third category of less than 50 volts, as you see here. As I said a minute ago, 2020 was updated in 2014. And going forward, companies at this moment in time can be certified to either the 07 version or the 2014 version through the end of this year. Starting in 2016, you'll be obligated to be certified to 2014. The changes for 2014 will have some new measurement requirements, measurement methods, which will also mean some new test equipment and learning the new procedures, which we'll summarize for you today. S2020 has many strengths, and it's our view that it's the best standard available and is designed as a basic level of protection for general applicability. It's been widely accepted internationally. It's active not only in just the industry, but also the armed forces. In fact, the armed forces asked the association to create 2020 as a replacement for DoD 1686. And the FDA has recognized it as well. Most OEMs specify 2020 for their supply chain, and most contract manufacturing companies use it, and many are certified to it. It's also compatible with ISO 9000, which is one of its strengths. It also allows the certification process adds credibility to the document and helps companies communicate with each other to certify the extent to which they have committed to the document. To date, there are 264 facilities worldwide that have been certified. It's compatible with most existing programs, and there is an international harmonization emerging. It's highly flexible and has broad limits both technically and administrative requirements. And again, we would like you to ask questions as we go forward. And to reinforce that, we have one question that came in early regarding explosion conductors and insulators in explosion protection. Unfortunately, that is beyond the scope of S2020. 2020 specifically excludes explosion. And let's see, the 250 volt limit is, there was a question here about 250 volt HBM or CDM and not for latent failure. The answer is It's 250 volts for the device sensitivity level, as stress tested per association standards on that. And Carl will take over at this point.
All right. It says that I'm Ted Dingelmeyer on the list here, but I'm not. At any rate, he and I trade off frequently setting up these webinars and WebEx things, so we end up somehow I got listed as being Ted. So, at any rate, some of the changes in 2020, it basically boils down to about 10 major changes, other than just some editorial things that have gone on. Trying to change the slide here. I'm not sure it's working, Ted. You might need to go ahead and flip the slides for me. One of the biggest changes to the document is scope. And the scope of the document has left the HBM limit at 100 volts. But one of the biggest advantages to the document now is it does address the charge device model, and it sets the threshold at 200 volts or higher. So if you have a good 2020 program in place, you should be able to safely handle devices that have been tested down to 100 volts HBM or 200 volts CDM. There's a note in a comment. We'll talk more about this. I have a slide that actually has the scope showed up, and it talks about how the CDM limit is really trying to control process-required insulators, and we'll talk more about that later. There's also a section of the scope that talks about a 35-volt maximum allowable on isolated conductors. Again, I'm going to talk more about that later, but that is something that's in the scope. You might see that. Try to flip this one more time. Go next. It's not. In the EPA, there's a couple of changes that were made, but when you're defining an ESD protected area, the 2007 version made mention of needing marking signs. That created some confusion in the industry. It really wasn't the intent, but that's what people interpreted it as, and we took that out. And we put in that simply the EPA needs to have clearly identified boundaries. Some companies want to use tape. Some actually changed floor tile colors, things like that to identify the boundaries. So now that's now allowed in however method the user wants to define that. The other major changes in the flooring qualification. When you're qualifying your flooring footwear system, in the 2007 version, it allowed you to qualify it by just measuring the resistance of the system, meaning from the operator to the ground. If you were done. What we found through various testing is that didn't always keep 100 volts off the person when they were walking around. So now the requirement is that you have to do both. You have to meet a minimum resistance, but you also, or a maximum resistance, but you also have to do this walking test when you're qualifying your flooring footwear system. The tailoring statement was changed a little bit, basically just to try to clarify it. There was some question about whether if you change your plan at all outside of ES of 2020, did you have to write a tailoring statement? And really the intent was not to do that. The intent was only if you eliminate an entire section that's required, a required section, or if you modified the requirements outside the standard. So Ginger's going to talk more about that later, though, so hopefully we'll clear some of that. Yeah, in the 2007 version, there was a note in the table that talked about product qualification. In other words, all of the items that you purchase to control static and deal within your plan, you've got to qualify it somehow. There's now an entire section of 2020 related to that. It's a required element now. And this is one of the items I think really beefs up the standard. in enforcing good quality products are purchased for controlling your ESD program. The other change that was made to the document is that we found people are using their garments. They're using fairly conductive garments or garments that have conductive elements in them to actually ground their operators. So they're eliminating the wrist strap and using the garment as their wrist strap. And we kind of beefed up the document a little bit to require garments to have sleeve-to-sleeve continuity. And when you're all said and done, the resistance to ground of the operator have to meet the wrist strap resistance requirements as in place in the wrist strap section of 2020 as well. So it provides a little more protection. Arnie is going to talk more about ionization, but as a summary, that was a section that was part of the document that was changed. The offset was reduced from 50 volts to 35 volts, and in the process of doing that, they eliminated the room system specification. In the old version, there was actually a note in the table about room ionization, and we've taken that out because in a lot of cases it's and Arnie will talk more about that. The other comment that's made in the document, that's a new comment made, is that there's a statement that says when packaging materials become work surfaces, you need to now, instead of having a packaging requirements for resistance to ground, you need to satisfy work surface requirements. Here's an opportunity for you to answer a question. Should packaging materials ever be used as a work surface? It's been a question that several people have asked. Anybody have a way to answer that, Ted? I don't know if you can see there.
I'm looking forward to see if anybody wants to offer a suggestion or a response.
Or an opinion?
Or an opinion. Opinions are just fine. I have one from somebody that says never.
There we go. And certainly the first thing, oh, go ahead.
No, I was just going to say that's actually what we agree with. So
yeah.
That's a good one.
Just to offer up a conversation point, though, the first thought that comes to my mind when you say packaging materials is an ESD bag, and certainly that's where one of the issues has come up where you walk through facilities. You see this in witness audits as well as in our audits as well, where someone has taken a board, for instance, out of an ESD bag, placed the ESD bag on the table, and then put the board on top of it, thinking that's a safe situation. And that would be a classic requirement or a classic situation where this would violate 2020, because if you were to measure resistance from the top of that ESD bag to ground, in most cases it's not going to be less than 1 × 10⁹ ohms. I think the intent of this was to allow certain trays, and a tray can be considered a packaging material, and in some cases you are working directly out of a tray. But in that situation, again, you'd want to make sure that that tray, from the top surface of the tray to ground, is less than 1 × 10⁹ ohms in order to meet 2020. If it's not, you need to change your process to allow for that. There were a couple of things added to 2020. There were some, in Table 3, we added a section on soldering iron requirements. And there's also requirements that something we noticed in doing witness audits is that many times people were qualifying a workstation. They would make sure the wrist strap worked. They'd make sure the tabletop was grounded, but nobody ever stuck an ohm meter between the wrist strap connection point and ground to make sure it was connected. So there's now a requirement in the table to do that.
Carl, before we go on to the next slide, I had a couple of questions come in on this topic.
Okay.
And you've answered them, but let me just repeat them to make sure we've covered them sufficiently.
Okay.
One of them is, as long as the packaging materials meet the requirements for work surface, why not?
Well, that's a good question. If they meet it, you just run the risk of the packaging materials can change in many cases, and so in that vein, you want to be very careful. It's not so much as a blanket requirement, and from our perspective of don't ever do it. It's a matter of how risky is it, because many times if you're using a packaging material and it becomes dirty or ungrounded, it's easy to become ungrounded, and so you may measure it once and it meets the requirement. You may measure it again another time and it doesn't. So you use some care if you want to take place in your process.
Yeah, the other thing I would add is, and then there's another response here saying, no, it's extremely difficult to control, and I think that's a good response. The risk that you run, well, let me put it this way. Work surfaces are carefully engineered and go through rigorous testing at high voltage, low voltage, multiple points, all kinds of various rigorous tests, whereas the packaging materials can have just too many variables to be confident that you're getting the same kind of performance. That would be my take on it.
Okay. I'm kind of going through the questions. I can read here too if you.
Okay.
So we had a lot of questions. That's good. I was afraid we would never see questions.
Yeah.
Okay. One question that came up regarding the flooring footwear, I noticed that was a question. I'm not sure Ginger covers this part of it, but if you currently have a floor installed, do you have to get it done? And that is a kind of a nebulous area, because there is a grandfathering clause in 2020 that allows you to use your existing compliance verification data for your flooring footwear system. From a best practices standpoint, what I would start doing would be start collecting that voltage, body voltage data at various times of the year to account for the difference in humidities that might occur in your process. And just start collecting that data so that you have it along with resistance data to show an auditor or an assessor, and just satisfy yourself that your flooring footwear system is working the way you want it to. Obviously, you can't rip up your floor and put it in a 12% humidity chamber like the qualification test requires you to do. But if you could do a consistent body voltage test on the different paths where you use on that floor throughout the year, it'll give you a good picture of what it's like and what it's doing for you. There we go. All of these changes, actually most of the changes won't affect this, but in some cases it is going to drive some, possibly having some new equipment that you don't have. For instance, if you don't have any ionization systems, you may not own a charge plate monitor, but to do the body voltage testing, you need some form of measuring the voltage on people when they're walking around on the floor, and that would involve either a charge plate monitor or another kind of high impedance voltage detection system, and then some kind of way of acquiring the data so you can analyze it later. So that's something you may need to go think about purchasing as you move forward. The other requirement that's going to potentially derive some equipment is the isolated conductors. Most of us have ohm meters, but that doesn't measure voltage on isolated conductors. That only measures resistance to ground, which you're going to see when we get to the final analysis. That's what we're recommending that you do, is make sure all your conductive materials are grounded so you don't have to worry about it. But when you're talking about measuring the voltage on an isolated conductor, that gets very tricky in some cases, because your standard field meter won't work very well to do that. It's going to underestimate what kind of voltage is present. So you pretty much have to go into some kind of an electrostatic voltmeter, or better yet, a contact voltmeter. And those are new pieces of equipment that not everybody has in their audit kit today. There was a question regarding this. Are hand tools such as screwdrivers with insulating handles considered isolated conductors? And my answer to that would be yes, they would be considered that. You got to be careful how you're using it, and that's the key. So I'm going to have a picture of a screwdriver plastic handle later as a demonstration of that. One of the show and tell things that we do at the workshop and when we teach tutorials is we use this 3-disc plate here. It has a fairly large plate. This is kind of hard to see on the scale, and I'll flip the next picture up. I'll make it a little more obvious what this size looks like. But there's 3 discs, and they all are connected electrically to a battery pack, which provides 45 volts on each disc. When you go to look at this disc, if you look at the large disc with a field meter, which you have to see the picture down here, I guess Ted's highlighting it. I'm trying to. I'm probably not helping. You see that, indeed, there's 48 volts on it. And likewise, if you look at it with the contact voltmeter, on the one on the left, that also says there's 47 volts on it. If you look at it with the electrostatic voltmeter, I'm not sure why it reads lower, but it does. It's 35 volts, but it's consistent. You can actually measure that on all 3 of these discs using different meters. When you go to the small one, you can see the contact voltmeter still measures 47 volts. But now if you look at the field meter, it's only measuring 12 volts. The electrostatic voltmeter is still measuring 34. So that's consistent.
Carl, I know if you look closely, you'll see there's a low battery light on, and that's why the electrostatic voltmeter is off.
Oh, okay. That makes sense.
We need to fix that slide. But it would normally be the 47 volts that you know throughout all 3 measurements.
Right. But the field meter doesn't see, it looks at a fairly large area and it averages it. So if you're trying to look at, say, a screwdriver handle with a field meter, you're not going to see the true voltage that's present on that screwdriver. And so it's important that you get the right equipment to do that measurement.
We have a question on smocks, garments.
Yeah, I saw that. I was trying to find it again. We're getting more and more questions here.
One of the are the sleeves allowed to be rolled up, or must they be down? Is the question.
If you're using the garment as a wrist strap, it obviously has to be down, and it has to be a very tight connection to your wrist. I think, in general, smocks are a good thing. They provide a lot of continuity for what the process appears when people are walking through it. I think it's the opinion of our organization, that our organization being the Engelmeyer Associates, that garments don't provide a whole lot of protection from an ESD standpoint. And so therefore, whether they're rolled up or rolled down is irrelevant. Do you agree with that, Ted? Anybody else want to disagree with me?
No.
Okay.
Yeah, I think one of the things that Carl is stressing is garments may be used for many reasons in your facility, so you know who belongs in which area. There could be a team coding going on with the color of the garments, but if they're not being used for an ESD reason, then it doesn't matter if it's short sleeve, long sleeve, rolled up. They're there for some different reason. And there are difficulties with using, you have to have very special garments and wash them a special way and replace them at certain intervals if you're going to use them as a grounding mechanism.
Okay. I promised to bring the scope up later, and here it is. This is the, almost, I believe, word for word out of the 2014 version of the scope, and we highlighted in blue some of the key points and changes to it. So you can see the first one still talks about 100 volts HVM. That's not a change. It has the 200 volt CDM and 35 volts on isolated conductors. And then they also mentioned that the CDM requirement is tied to, I'm sorry, on that first note, the CDM level is based on managing process required essential insulators. It does state that, if you're handling devices that are lower than these voltage levels, you may require additional controls or adjustment limits. And then they tie the isolated conductors are tied to the old MM requirements that were running around in various documents. MM is kind of falling out of favor in the industry. There's a lot of controversy related to that. But in terms of testing devices, you'll be finding fewer and fewer devices are tested to an MM standard because the standards are being downgraded internationally as well as in the United States. But there are still devices that have MM data, and that's part of the reason they wanted to keep the 35 volts mentioned in the document. I'm getting a lot of comments about the packaging. I'm seeing that that you've got packaging is not usually very well grounded and not well controlled and things like that. So seems to be a lot of agreement that try to avoid using packaging as a work surface. Can't get the slide to change here, Ted. Or maybe it's my controller or yours, but there we go. There are two strategies to take care of charge device model and charge board event mitigation. There's two methods that we like to deal with are either lowering the device voltage or using a higher surface resistance in the discharge path. And there's two different strategies, and of course, which one is tied to 2020? And it's tied to what's in the scope. You can measure that. You can kind of see that in the kind of read between the lines in the scope. And they talk specifically about lowering the voltage on the device. One of the things we have found works very well too is to certainly do that as best you can. But even some of the very, very sensitive devices we've been dealing with, you can't get rid of the voltage completely. And so we've found that we create a situation where we have higher surface resistance in the circuit where it's discharging. We can get good results from a yield standpoint. So basically what we're doing is limiting the discharge current, reducing it down to a level that's safe. Prevent the spark, you prevent the ESD damage from a CDM or charge board event methods. Again, the lower device voltage is tied to charged insulators. The higher surface resistance is adding a surface resistance requirement to your ESD control plan. So that's our recommendation. Use dissipative materials at your point of contact. Whenever you make contact with your device, since the circuitry on the device provides some surface resistance, and that'll help prevent CDM type damage.
Carl, we have another question that came in on, this one is on the machine model, and it says, isn't the machine model still a valid failure mechanism in a EMS type plant or contract manufacturing facility? Want me to take that one, or do you want to go?
Yeah, if you'd like to, go ahead. Yeah.
The machine model has been downgraded by all of the major standards bodies and is no longer part of device qualification. And the history of it, there's a lot of reasons why it's been downgraded. In fact, it's never actually been a failure mechanism that replicates real-world failures. So major IC suppliers like Analog Devices have told us clearly that in all of their years of doing failure analysis, they have never seen a failure from the field that was machine modeled in nature, or in other words, they have not seen any connection to real-world failures. It was originally developed as a low-voltage HBM stress. And we can talk more about that offline. It's, if anybody wants to, we'd be glad to. So I'll turn it back over to you, Carl.
Okay. And flip the slide. There we go. The CDM 200 volt requirement in 2020 is, again, they mentioned in there that it's managing process. It's tied to managing process required insulators. The 200 volts, it's not super clear where that number came from. It's probably a reasonable number. We tend to focus on a lower number in a lot of our customers that we deal with. It does apply to integrated circuits, but not necessarily integrated circuits on circuit boards. We found that boards can fail at a much lower voltage than a standalone IC. When you talk in charge device model, you've got to deal with the capacitance of the item that's being discharged, and that's what that really comes in. A circuit board with many devices on it has more capacitance and therefore can get much higher discharge currents and cause failures. The issue, the standard doesn't really include any kind of surface resistivity requirements, and we think that's important. So that's one of our recommendations. So the question becomes, should 200 volt CDM be a solid capability of 2020 or not? And we believe probably not. In many cases, you've really got to examine your process and the parts that you're handling. But it's a line in the sand. It's better than it was. There was no requirement before. Now there is a requirement, and then everything is a stepwise process, and that's what we're trying to get to with the standards. So. We believe surface resistance requirements are necessary for many applications. Some advantages to it is it's less expensive. It's basically a table mat in many cases, or a dissipative tooling like tweezers or wire bond tips, things like that. It's less prone to human error, and we believe it's essential for the more sensitive devices that are being built and handled today, and it's just going to get worse as time goes on. So the best practice, of course, is to blend some surface resistance requirements and controlling insulated materials. That's the best approach, is to do both. You can eliminate the voltage from the devices as much as you can, but then when that doesn't happen, you can use that to use the resistance to satisfy that. This is a chart that we have used, and it's actual real data from a factory, a customer of ours, that we've done to show that the first section of this is tied to, this company had a good S20 2007 program in place. It was, again, focused on HBM. There was some work on eliminating process required insulators, but there was still a lot of holes in the program. And when we started digging into it, now this is a very sensitive device. It was a class 0 device, and we went in and did a technical assessment and evaluated the CDM and surface resistance and had them install some very significant surface resistance things. And you can see that the yield loss started coming down. Now, before they even implemented the program, failure was even higher than you see on the chart. But even with a good 2020 normal program in place, they were still seeing losses as high as 22%. So after we implemented the 2020, it came down. Then we implemented some surface resistance requirements. It came even down even further. And as we worked with them more and more to eliminate metal-to-metal contact kinds of things and getting better processes in place and just managing the program better, you can see their yield loss came down even further. And it's to this day, as far as we understand, it's maintained at a very low level for yield loss. Do you have anything to add to that, Ted?
No, I think that's great. That's good.
Okay. This is a chart that was given to us by Andrew Olney over at Analog Devices, and it's talking about so the device. He took a device and he charged it to a 250 volts, and he did a discharge. Measured the discharge current, and the failure current was about 5 amps. And at the device level, it satisfied that. Unfortunately, when you take that same device and put it on board, the board that it was supposed to go on in the part, charged the board up to 250 volts, he got about 9 amps of current, which destroyed the device. The point being, of course, is that you've got to evaluate the issue of handling boards in a process, and in that case, your charge device model or your threshold may not be valid once the part is on a board like this. So the device still fails at that, but that's a device level test. So you need to be very careful about how you implement your process and view how sensitive the devices are that you're putting in the process. So some considerations. I promised we'd talk about isolated conductors again, and that's what this slide is for. the comment in the document is that isolated conductors, it says, ensure that the difference in potential between any conductor that contact ESD-sensitive items is less than 35 volts. Later or actually earlier in the document, it does make a comment that all conductors that come into contact with ESD items shall be at the same electrical potential. So basically, they're saying you got to ground the conductors, but we all know that in a real-world situation, there may be some conductive items, i.e., circuitry on a board, a ground plane on a board that may not, you can't ground it. And that's the intent of this statement, is to make sure that you are looking at those kinds of conductive items and making sure they're grounded. Rotating end effectors on robots is another possible situation, and where you just can't ground it. And again, we advocate grounding it as much everything you can. This, in my mind, not allow you to take a screwdriver, for instance, as somebody mentioned in a question, with a plastic handle on it, and use that screwdriver to touch ESD-sensitive devices, because you're going to damage parts. The heartburn that we have with this requirement or this comment in the standard is not the intent that's kind of hidden behind it, but what could come out of it is someone could say, well, that means I don't need to ground my carts, or I don't need to ground these large pieces of metal like a screwdriver. And if you do that, you're now taking an item that has a very high capacitance. You may only measure 20 volts on it, but because the capacitance of that item is so high, you still create a huge discharge current. And so you could still damage product with a conductive item that it has less than 35 volts on it. So our recommendation is that you set the resistance or ground requirements for isolated conductors per voltages on isolated conductors at all. You've got to ground them. Follow section 8.2, not 8.3.2 in the document.
Carl, before you move on, we have a good question on a previous slide. And the question is, for the CBE slide, is the 9 amp current the current at the component or board?
Okay. The test that was done was actually, he would charge the board, the component and the board up together, and then he would discharge to the component. So it would be simulating, say you have a charged board and then you reach in with a soldering iron to fix a solder joint or something on the board. That would be kind of a simulation of what you're seeing there.
Yeah, so it was actually part of a larger investigation where they had field failures and field returns, and they were able to duplicate the damage only with the charged board event in a manner that, like Carl described.
Okay. This is I promised earlier we actually show a picture of a screwdriver. This is a subject of an investigation we did. This is where we took a screwdriver, we rubbed the handle of it, and we measured the discharge current using a CT1 current probe and an oscilloscope. Trying to forget the other items on this slide here. So when we did this, we measured 1,000 volts on the handle. That was what measured with an electrostatic voltmeter. We measured 28 volts on the metal tip with a contact voltmeter. And when we did the discharge, in these kind of tests, you got to do many tests in order to understand what kind of discharge you're getting. But we measured between 2 and 7 amps of discharge. In most cases, that's going to be a problem for most devices if you're making contact with circuitry. Now, I was just in a factory a couple of days ago where they were using plastic handled screwdrivers, and all they were doing was screwing chassis together. And the question was, can we use this? And I said, well, as long as you're not touching circuitry with those screwdrivers and you can verify that that never happens, it's probably okay. But I think I would still start moving towards getting a hold of screwdrivers that have a dissipative handle on them, just for the off chance that somebody uses it to touch a circuit board or something. So.
And as you can see in the white bullet line up in the top here, in this particular example, this very screwdriver was the root cause of a significant problem to circuit boards. and device damage of a CDM nature.
Hello, this is Ginger Hansel, and see if my clicking's working. There.
Yeah,
so this is the new table that's in the 2020-2014 document. And those of you that are familiar with the 2007 document, there's a major difference. The 2007 document had 2 tests for measuring flooring and footwear and flooring. And you could do a less than 35 megohm resistance, or you could do a walking voltage test, which had to be 1 times 10 to the 7th, less than that. In the 2014, there's only the method 1 that was in 2007 isn't there. There's one method for testing the flooring, and it includes both the STM standard test method 97.1 and STM 97.2. So your resistance of the person through the footwear, through the floor to ground for qualification is less than 1 times 10 to the 9th. And when you do the walking voltage, any peak voltage on the person should be less than 100 volts. The requirement for compliance verification currently just has, I'm not sure if my keyboard is actually making anything happen, Ted. There. So that the 35, less than 35 megohm resistance has been removed. And Ted, you'll have to hit the next one. And our recommendations are that that you standardize on the footwear and the flooring that you use. So whatever you do to qualify the floor, the compliance verification should use the same footwear and the same floor. There's too many chances for differences to occur if you change footwear and flooring, and we'll show you an example of that in a moment. Also, the compliance verification strikes us as a little bit too large a limit there, where it's 1 times 10 to the 9th. We recommend that you take the resistance measurements that you got when you could keep people under 100 volts and use those resistance measures. So for example, if the flooring and footwear was, if your footwear is normally 1 times 10 to the 6th, you could set a limit that it would have to be less than 1 times 10 to the 7th. That gives you a little bit of a range to tell if your footwear is not working properly or if somebody brought in the wrong kind of footwear. And if you make any changes to the flooring or to the footwear, then you'd need to requalify because now you have a new system. I think that's the major difference in this section on 2020 is you're looking at it as an entire system, and so if you change a component, it has to be requalified. And for compliance verification, you want to focus on the system that you first qualified. So in this slide, you can see Ted Dangelmeyer is holding the electrode, and Arnie Steinem, who you'll hear from in a minute, is holding the charge plate monitor and gathering the data. And we have a schematic of a possible walking pattern. This is often known as the ESD shuffle. The idea is that you would be stepping backwards and forwards and side to side as somebody might step while they're doing work in the work area. By standardizing it, you have a chance to get a repeated pattern, and then you can see various peaks in the walking voltage.
Ginger, we have a good question on this topic. Should a wrist strap be off when doing this walking voltage test?
Yes.
Clearly it has to be off so that you can monitor body voltage.
Right, because your body voltage will stay at ground with a wrist strap. This is a very good way to test if a wrist strap is not working properly. Occasionally we get questions about wireless wrist straps. You could try it in your factory and you will see that a wireless wrist strap works about as good as no wrist strap. But a grounded wrist strap will definitely keep the person to ground. Which is also one reason that I think Arnie's holding the meter and Ted's just holding the probe, because this particular meter is somewhat dissipative and it is connected to ground. So you kind of need a partner when you're doing this test. Next slide, Ted. On our website, the Dengelmeyer Associates website, down on I think line number 9 down here, we have many videos on how to do various ESD testing, and there's a video explaining how to do the walking voltage. Since this is now a required test, there's an awful lot of interest in how to do it properly and repeatedly, and it's kind of new for some people, so try to give you a guideline where you can go and watch it over and over and over.
So to get there, you just go to the home page, click on the video button at the top here, and then go down to video number 9.
Next slide.
Yep.
So this pattern here was generated by doing 4 repetitions of the ESD shuffle. You can tell there's a little pause in between each one, so you can see where the walking was done. This was done on a conductive vinyl floor, but the shoes were not ESD-controlled shoes. So they were plain street shoes. You can see there's quite a lot of charge from the standing voltage of about minus 500 volts up to the peak of almost 1,500. There's almost a 2 kV swing of voltage. So this would not be something that you would want to have your sensitive devices subject to. So you would need to have a good floor and good shoes. The whole system needs to work for this to provide a grounding path.
And we have.
There was a. Oh, I was going to. You're probably going to have to do the same thing I said. I led up the question regarding footwear.
No, go ahead. I had a different one, but go ahead.
Okay. Somebody asked a question. I answered it on the text, but on the text box. But it was asking if every brand or version of flooring or footwear has to be tested, and ideally that would be the case, because if I tested with, say, a brand X heel strap, I will get one set of voltage. If I test with a different pair of ESD shoes, that can be completely different. So unfortunately, that's what the document says, is that you need to test all the different kinds of flooring and footwear combinations that you're going to use in your factory.
Which is a good point, that it's important to select what you're going to use and try to standard on it as much as possible so you don't have quite that many variables that you have to manage in your ESD control program. And we often refer to ESD shoes because most people know how to put their shoes on properly. There's a lot less training involved, even though heel straps or heel grounders seem like a more cost-effective solution in the long run. ESD-controlled footwear may be more economical, so we're mentioning that for you. And Ted, I can't actually see the questions, so if there's more that have come up, please let me know.
I would certainly will. There's one here that's on a previous topic, and it begins with SRM, for surface resistance measurement. Why is the lower border, and I assume limit is meant by that, gone for static dissipative surfaces? Well, that's actually what one of the issues is, that it's not really the resistance to what you're talking about. I'm getting tongue-tied here. Sorry. In the document, there are several resistance to ground measurements where everything has to be less than 1 × 10⁹ resistance to ground. That is not a surface resistance test. A surface resistance test is either point-to-point or with the concentric circles, and that is actually at the heart of one of the issues that we're concerned about. We'll talk a little bit more about that going forward here. And you want me to change slides? Oh.
Yeah.
You can try yours again, Ginger. It may be working again.
But I don't want to change right now. So the walking voltage comparison, this slide has shows using two different types of floors, but with the same ESD control shoes. So you can see there's quite a dramatic difference between the dissipative vinyl floor and the conductive rubber floor. The pink line is the dissipative vinyl floor. You can see there's a fairly high peak of 85 volts, which is technically still under the 100-volt limit that's mentioned in 2020, but it's pretty close. So if you've got very sensitive devices, that may not be acceptable limit in your control area. The rubber flooring actually keeps the walking voltage around the 25-volt peak, which gives you a lot better margin for error if you have very sensitive devices to use a footwear flooring system that is that well controlled. And once again, you should maintain a tip for a qualified system. Make sure it's the same footwear and the same floor. Yes, Ted?
Standardization is always a good way to go for all aspects of the program. We have another question here that's interesting. Does a material handler, meaning a person, that does not come in contact with material outside of packaging, but may walk through various work cells, need to have heel straps if he or she is not coming within 1 foot of the product at workbenches? That becomes a user-defined requirement. You have to decide what is appropriate and what the probabilities are of accidental contact. Some companies prefer to have it be consistent and have everybody grounded. Some like to add confidence that there won't be human error. So there's several things, but it's user-defined is the bottom line. If you're beyond a foot from the product, you are technically okay, but may, for other reasons, decide to require grounding for anybody in the area.
And before we get off the footwear flooring section, I want to emphasize in the S20 2014 in section 8.2, there's an important footnote on that table 2 that we saw earlier, for compliance verification, where even though it says that for compliance it should be less than 1 times 10 to the 9th, that it's set that limit at what you found to be true when you were meeting the less than 100-volt walking voltage. And there's a footnote that spells that out, that the 1 times 10 to the 9th ohms is a maximum allowed value. But the user should document the resistance values that were measured for product qualification for the footwear and the floor to comply with a less than 100-volt body voltage generation, and use those resistances for compliance verification. That's an example of a very important detail being down in a footnote and might have gotten overlooked when you were going through the standard. So the next part, the next slide.
We have a couple more good questions here.
Oh, okay. Excellent.
One is, how does conductive vinyl compare to conductive rubber?
Well, what we're talking about here is measuring the system, and different materials in conjunction with different shoes will give different results. So a blanket statement about this kind of material always does this and this kind does something else, there's different formulations. I mean, frequently rubber seems to be more homogeneous and give better results, and with dissipative vinyl, often there are insulated areas coated with conductive material, so that makes for different characteristics, because you actually have little insulators that are coated with carbon around them. And So that's one reason you have to test specifically the floor that you're going to be using when you're doing qualification.
Yeah, on
average, you want to add to that, Ted?
Yeah, I was just going to say, on average, rubber tends to be low charging, whereas vinyl is high charging when you're walking on it in street shoes or ungrounded carts or anything of that nature. As I say, rubber tends to be more forgiving, and vinyl tends to be high charging. There's another related question. How do you feel about using ESD waxes versus conductive rubber or dissipative flooring? The ESD waxes or finishes work surprisingly well, and they also are low charging and work effectively even on non-ESD flooring underneath it. But it requires a lot of maintenance and comes with its own headaches. Typically, when there's a problem with ESD wax, the root cause circles back to the application and errors made during application. Let me just do this one more here. Let's see if it's a good time to answer it now. The question is, should flooring footwear qualification take into account flooring maintenance, cleaning materials, and frequency? Well, certainly that's an important consideration. The intent of the qualification with 2020 is to measure the two items in question in order and qualify it for that. The maintenance aspect of it is part of your overall quality strategy and plan for sustaining the high level of performance that you got during qualification.
Right, and I would also add that for compliance verification, you should check those areas that get a lot of high traffic, that perhaps the floor is dirty, you're there, or if it's a surface treatment, it might be worn. And so that would give you confidence by testing in the most difficult areas. If you're still within your specification, then you'll have more confidence that your program is designed properly and being maintained properly. So now we're going to switch to talking about tailoring. Carl gave a little introduction to that. This document was updated in order to clarify some issues. Of course, with any standard, when you clarify, there still can be questions. One of the strengths of 2020 is that you can make changes. But just on this slide, just to highlight that the changes are in blue there, that the requirement may be deleted or modified outside the standard, the limits of the standard, then you would need a tailoring statement and the technical documentation as to why you made that change. If you add a requirement that's tighter than a limit in 2020, you don't necessarily need to have a tailoring statement. For example, on the walking voltage test, where it must be less than 100 volts on a person, if your program said it should be less than 75 volts in the walking voltage, you don't technically need a tailoring statement for that because you're well within the limit set in 2020. And let's go to the next slide because we have a lot more details there. So basically, tailoring, the intent is it's required if you're going to delete or modify a requirement so that it's outside of the specifications. And somehow my, I don't know if I'm clicking or you're clicking, Ted, but it seems to be working. There are a list of required elements in 2020. If any of those are eliminated for some reason, then that would require a tailoring statement. But it must be technically justified and documented. And an example of that would be in the 2020, it states that workers that are seated shall be grounded with a wrist strap. And if they're standing, they can either use a wrist strap or a footwear flooring system for personnel grounding. So the element is that personnel need to be grounded, and if they're seated, they need to be grounded with a wrist strap. If there's a reason, some other reason in your facility that you don't want to use a wrist strap, then you would need technical documentation that would, and data that would show that the people are grounded in an alternate way, and that could be in your program. Are there any other questions about tailoring? I know we spent a lot of time discussing what this means when we were putting this training together.
I just added the last bullet there too, Ginger.
Okay.
So for table 3 in the document, if you're able to delete items in that table without a tailoring statement, as long as you don't violate.
They're optional.
Yeah, they're optional, as long as you don't violate these others. Now, just to add that this list of 7.2 through 7.5 and 8.1 through 8.5 is our interpretation of the phrasing in the tailoring statement. It's not clearly spelled out in the document, but this appears to be a logical interpretation of it.
Ted, there's a question about this. The question is, who determines if the justification is adequate or valid? And ultimately, it boils down to you and your customer. If you're going to get certified to 2020, the auditor is just going to look for a justification. He's not going to interpret that. So it's really up to you and your quality organization and your customers.
And typically, most programs don't have a tailoring statement. They can put their program together based on 2020 and what other requirements they have, and tailoring statements aren't actually necessary. And as I mentioned earlier, if you have a tighter limit, you can put it in your program as a tailoring statement, but you don't need the technical justification because you're within what 2014 says. If it's outside the limit or you've deleted an element, that's when you need to note why you did it. And as Carl said, as long as you and your customer agree that it's adequate, then that's what really counts, but it needs to be part of your program. Is there anything else on tailoring, Ted? Because I think we're ready for the next section.
Yeah, the question related to what you were just saying, the question is if the floor does not meet less than 1 times 10 to the 9th requirement, can this be tailored to 1 times 10 to the 10th? Yes, it can, and that's where you'd have to write a technical justification, have data to back it up, and ultimately your customer is going to be the one deciding if it's adequate justification or not.
But it might be difficult to be under the 100 volts walking voltage if your floor is not dissipative enough. So that, I mean, there's that factor to be aware of.
So you'd need to certainly, to Ginger's point, you'd certainly need to do walking voltage tests. As a counterpoint, ESD wax sometimes will measure in the 10 to the 10th range with walking voltages still down below 10 volts. There's another question about how often flooring should be tested. That's a question that varies on the flooring that you've chosen and its long-term stability. For instance, if you use ESD wax, I would test it every week or anytime you see evidence of a spill. Water on wax will compromise its performance. A conductive vinyl floor is much more durable and might, testing it monthly or some other interval may be perfectly appropriate. The bottom line is to do it.
Rubber floors are even more durable, but we often recommend letting the data help you guide how often you need to do testing. So if you start out with a very tight test schedule, as Ted mentioned, and you don't find any deterioration, then you could lengthen the amount of time between tests. But always test in the working conditions. So test don't clean the floor first and then test, because now you've changed the conditions that it's actually functioning under. So test it in an as-is condition in the high traffic area, and that should help you decide how frequently you need to test to make sure it stays within your guidelines. Thanks for the good questions, everybody.
Hello, everybody. This is Arnie Steinman here. One of the next sections that was changed in 2020 is the product qualification plan requirement. While the previous editions of 2020 did require product qualification, now the 2014 version requires you to have a documented qualification plan. So in section 7.4 of 2020, you'll find the information about having a product qualification plan. Obviously, it says it should be established. And then it talks about the methods you can use for product qualification. The first being product specification review. You can take the manufacturer's data sheets for the ESD control products you're using, and if they contain a statement that the product was tested according to the ESDA standards, this will usually be sufficient for product qualification. You can also use an independent laboratory to evaluate your materials, or you can conduct an internal laboratory evaluation. Any of these methods written into your product qualification plan will be acceptable. For ESD control items that were installed before the adoption of 2020, they've kind of grandfathered in by saying that if you have ongoing compliance verification records for the materials you've been using, that you can, essentially use those as your evidence of product qualification. Excuse me. Sorry about that. So basically, if you have ongoing compliance verification records, you can use them as evidence of your product qualification for materials that you've been using for a while. Next slide, please. Okay, now we're going to take a look at Table 3, the table that has your EPA ESD control items. And what we've done is highlighted the items that have changed from the previous document. What has been added is to monitor the personal wrist strap connection. This was not contained in earlier documents, and it's now been added. And essentially, you have to verify that from the wrist strap connection point to ground is less than 2 ohms. Both for qualification and for compliance verification. We've already talked about how you have to do a compliance verification of your footwear and flooring system and the qualification of that system, so I won't go into that again. Next slide, please. There's been some significant changes in the ionization section. First of all, the separate specification for room ionization has been deleted. There's only one specification that all ionization is supposed to meet, and we'll talk in a few minutes, we'll talk in a little more detail about that issue. Also, the acceptable offset voltage from the ionization method used to be 50 volts and now has been changed to 35 volts. Again, we'll talk about that in a moment. The electrical soldering and desoldering hand tools, this has been added to Table 3. It was previously in the annex of the document, but they've decided that it needs to be, more clearly specified. Nothing has changed in terms of the requirements, but now it is contained in this Table 3. Next slide, please. So one of the changes that's occurred is what is required on process essential insulators. And first of all, let's discuss what a process essential insulator is. It could be tools, it could be fixtures, it could be chemical supply bottles, it could be part of the equipment. These are all possible process essential insulators. But a process essential insulator could also be part of the product itself. When you look at your products, think about which one of them has an insulator in it that you could not move away from the product itself. So we also need to think about process essential insulators as part of the product. Now, in a previous document, fields over 2,000 volts per inch on process essential insulators were said to either require ionization or separation from the ESDS item by 12 inches or more. That was the existing requirement in 2020. Now, the new requirement in 2020, next bullet please. The new requirement that's been added is now it says that a field measurement of greater than 125 volts per inch on a process essential insulator requires the use of ionization or a separation of the charged insulator by 1 inch. Now let's take a look at that. Is separation alone a good strategy for protecting ESDS items? Let's take a look at the distance issue in more detail. Next slide. So here you see what the implications of the two measurement distances are. Up to 1 inch, anything over 125 volts is not okay. You have to do something about it. And up to 2,000 volts, you have to keep it 12 inches away. But what about the distance range between 125 volts and 2,000 volts? It seems, if you look at this, that between those two distances, anything that's over 125 volts and under 2,000 volts seems to be okay. But think about it. If 125 volts at 1 inch may be an ESD hazard, then 1,999 volts at 1.1 inches is certainly still an ESD hazard. So distance strategy alone is not a good way to really keep your devices safe from fields on process essential insulators. And in fact, between those voltage limits of 125 and 2,000 volts, ionization is not required if the distance is greater than 1 inch. So a distance strategy alone is not sufficient to protect your devices. Next slide. So 2,000 volts per inch at 1 inch is allowable breast 2020, and that's a high CDM and CBE risk for many products. And we know that boards charged to as little as 100 volts may still be at high risk. So distance alone is not a good strategy. In addition, that high-risk insulator is often part of the product itself, and you can't even you can't get a 1 inch separation of the device from itself. So the question, becomes what mitigation techniques are best? And basically what we recommend is that you maintain that 12 inch keep out zone for process essential insulators. Forget about the additional requirements at 1 inch. Keep any process essential insulator 12 inches away from the sensitive devices. Then you need to conduct an engineering analysis. Will you need ionization? Will you need to use dissipative materials? Because eliminating metal-to-metal contact is essential for maintaining a CDM risk-free environment. And then you might need to be monitoring your operations to assure that they are ESD event-free no matter what you're doing. You're going to need more training. People will need to be trained to use instrumentation properly, to make the measurements properly. As you saw earlier in our presentation, using just a field meter may not be giving you accurate information, and if you're going to use other advanced instrumentation, you're going to need to train people so that they can make their measurements correctly. Next slide.
Yeah, just before we get into the ionization, Arnie, we have two more questions. One comment here is, so the wrist strap box to ground is now 2 ohms instead of 1, and that is correct. And then the second one, does the wrist strap test need to be done when using a monitor? And the answer is no. The 2 ohm test is for the manual wrist strap grounding connection of the wrist strap at the bench. And let's see. Are insulated wires insulative wires connected to an ESDS part considered process essential? Sure.
I would say yes, they are. In fact, folks in the disk drive industry have always had an ESD problem that was caused by the insulating wires on the extremely sensitive magnetoresistive heads.
And it also brings up the concern about the cable discharge event. We see that frequently in circuit board assembly operations where wires are added to the board that trigger strong cable discharge events to the board and can be destructive. Okay, that covers the questions, Arnie. So you should have the first bullet. Did we lose Arnie? Where'd you go, Arnie?
Says he go online, but I don't hear him.
He's still there, but I don't hear him. Well, Arnie, pipe in as soon as you get back online. In terms of ionization, the offset voltage has been reduced from 30 to 55 volts. And one of the key things, and I know it's one of Arnie's major concerns, is that the room system element has been removed from the document. So there's no separate specification now for room systems. And the question we offer here, does that pose a problem? One of the issues that comes up is that a typical room system has an offset voltage of 100 or even 150 volts. So that would be...
Can you hear me again?
Yes, we can. Arnie's back.
Okay.
Hey.
Yeah. Network problem.
No problem. Okay, go ahead.
So I guess you see the slide here. You have heard some comments about it. The offset voltage for ionizers was reduced from 50 to 35 volts. Question is, why was this done? Was it done to match a requirement in JEDEC documents? Perhaps. Certainly it doesn't seem like changing from 50 volts to 35 volts would be relevant for protecting devices at a 200 volt CDM level. So it's really not clear why this change was made. They deleted room systems, and now there's no specification for room systems. And the question is, does this pose a problem? Because a typical room system offset is about plus or minus 100 volts. And if you were to adjust a room system for plus or minus 35 volts, it would probably be ineffective. And many of room systems are not used for ESD control. They're used in factories for contamination control or when ESD caused equipment lockup is an issue. So the question is, what do you do about this? If you want to continue to use room ionization because it's important to your process, how do you deal with it in the 2020 plan? The first way to deal with it is just to exclude it from the plan. Don't mention it. The downside about this is that when you don't have it in the plan, there's no guarantee that it's going to be audited and calibrated. So it kind of disappears from view, and you run the risk that your ionization system may have problems that you're not going to find during your audits. So it would seem like it would be better to keep it in the plan. To do that, you need to write a tailoring statement. For example, you could say that room ionization is used for contamination control and that local ionization meeting the 35 volt specification will be added wherever ESDS items are handled. It doesn't need to be any more complex than that. But it's important to qualify the ionization for the plan when you also have ESDS items that are being handled. Next slide.
Okay, just before we do that, there are a couple of questions. One, what is offset in regard to ionization? I think that's a good definition.
Yeah, offset, when you read the ionization standard, STM 3.1, it defines two tests for ionization. The first test is discharge time, in other words, how long it takes for the ionizer to reduce a known charge. And the second test is the offset voltage or balance measurement. What voltage does the ionizer itself balance to? That's the specification we're talking about in S2020. It now says the ionizer must be balanced to 35 volts or less. So offset voltage, balanced voltage, kind of the same thing.
There's another question regarding ionizer performance, and this individual purchased ionizers that specify less than a 50-volt offset. The question is, can we do better than that? And the answer is yes. You can get nuclear ionizers with a 0 offset, the perfect balance, guaranteed all the time. So yes, there are plenty of options for ionizers that will meet this 35-volt limit.
Yeah. Typically, the ionizers that people are using in electronics applications come out of the box with 20 to 25-volt limits, and there are certainly, you know, other ionizers that are available, as Ted mentioned, down to 0-volt balance. It's, you know, again, this is usually a question of how much money you want to pay for the ionizer. Now here's an example in the slide here of ionizers being used in a clean room. They're there in a hard disk manufacturing facility, and they're installed over the manufacturing process. The main reason they're installed there is to protect the equipment that's doing the process from discharges that occur when they handle the charged disk media. This is an equipment efficiency issue. They are also there to reduce the deposition of particles onto the charged media, and this is a contamination issue. And finally, during the disk verification process, the ionizers help to assure that ESD events will not occur to the sensitive MR head assemblies, and this is an ESD damage issue. But due to the extreme sensitivity of the MR head, additional local ionization balanced to less than 3 volts is used during the verification steps because you need to protect the MR heads at very low levels, and the room ionization system would not be capable of doing that. So when you use ionization in your factory, if it's only local ionization, it should be able to meet the 35-volt specification, but if you're using room ionization, you'll typically need to write a tailoring statement to explain why the room ionization is there and that you will use local ionization where you're handling your ESDS devices. Any questions?
No, we're good for now.
Okay, Ted. I'll hand it back to you.
Here, I'm not going to spend a lot of time. Here's a summary of what we've just said. And some added points. We recommend additional requirements to cover Class 0B, 0A, and 000, as well as for the charge board event, cable discharge events, and charge device model. There's quite a bit of detail to explain that, and the details would take us beyond the scope of this discussion, but we see the need for those added requirements for many applications. You saw the scope changes. We've talked about them, and one of the things that we're recommending is that you consider the 200-volt limit in 2020 as a guideline, and especially for circuit boards, set a maximum allowable potential of 50 volts. Rather than something higher than that, like the 200 volts is a high risk for a circuit board. And again, add surface resistance requirements for complete coverage of CDM protection. And we do not recommend using packaging materials as a work surface. We suggest disregarding the 35-volt allowable limit on isolated conductors, and instead of that, set a resistance to ground requirement that makes sense. In other words, do not permit voltages on isolated conductors, or follow Section 8.2 in 2020 instead of 8.3.2. Flooring and footwear we've covered quite thoroughly, and for what we're saying is, you know, standardize on the footwear and flooring that you used initially, and periodically repeat the walking voltage test to make sure that you're still in compliance. Process insulators, the bottom line is we recommend keeping a keep-out zone of a foot, that is workable, manageable, and anything closer than that, you need to do an engineering analysis to see what is the most technically and cost-effective remedy. And the bottom line there is you may need advanced training for that. Room ionization, add it to your plan. If you have room ionization and in the EPA you have ESD-sensitive product, then we recommend adding it to the plan and defining an appropriate offset voltage for your room system and create an appropriate tailoring statement. Clearly, the room ionization needs to be qualified like any other element of your program. And coming down the home stretch here, as we said earlier, this July we have our workshop, and would enjoy having you there. In fact, everybody on this call will be there with a limited class size of about approximately 20 people. So it's a unique learning opportunity. And thank you. We're right at the bewitching hour. Great questions. Glad you could participate, and don't hesitate to follow up with additional questions. We'd be glad to help with that. And to remind you, this whole presentation will be available on our website next week as a recorded video of today's presentation. And with that, I want to thank all of the team members, Arnie and Ginger and Carl, and I know Terry is eavesdropping in the background there. Thanks for all your help putting this together, and we look forward to meeting with all of you in the near future.